Continuing our lesson with rational expressions, we are going to learn how to add and subtract them. With any fraction, to add or subtract, you must have a common denominator. So let's use number 1 just to help us identify common denominators. Our denominators on number 1 are 5 and 3. So the least common multiple for those two is a 15. So that means that the 3 over 5 would need to be multiplied by an equivalent value of 1, where 3 times 5 becomes 15. And this one would need an equivalent value of 1 to get the denominator to 15. So that when we combine these, we end up having 9 over 15 minus 40 over 15. We can then do our subtraction from here, negative 31 over 15. So we're going to kind of do the same thing. It gets a little bit more complex, but again, a good start is to factor anything that has to be factored. Let's look at number 3. Looking at the denominator and the numerator, nothing needs to be factored here. So we're going to find the least common multiple. Basically look at what does the first one have that the second doesn't in terms of the denominator. The second one does not have a 4 or an x plus 4 quantity. So we're going to want to multiply by an equivalent value of 1, which has the missing piece, which is an x plus 4. Similarly, the first term, its denominator does not have a plain 4 all by itself. So it needs to have an equivalent value of 1 that is created from the missing 4. Notice, our common denominator then is 4 times x plus 4. That is the common denominator between the two. The numerator would be 4 times 3 plus, and then we have to multiply these two quantities together. And so when you FOIL that together, you get x squared plus 6x plus 8. Okay, so we've combined all that together. Go ahead and clean it up following PEMDAS to go ahead and combine everything. So when we add these two quantities, we end up getting x squared plus 6x plus 20 over 4x plus 16. That is what you get when you add these together. You can check to see if it simplifies. You could look at this to see if, can I factor x squared plus 6x plus 20? Okay, that does not have any, let's call them easy factors or obvious factors. Okay, so we aren't going to have anything that ends up simplifying any further. So this becomes our solution. It's a state restrictions to the domain. Okay, your restrictions to the domain are exactly what you think they are. You look at your denominators, okay, all the way along, look at all your denominators. Okay, so we have, let me get a highlighter out here. Okay, we have this, and we have this. Okay, check those denominators to see if there's restrictions. Here for x plus 4, x is not allowed to be a negative 4, right? It can't be a negative 4. The other term has just a 4. That does not have any restrictions because there's no variable that can create an undefined situation. And we know that this new one is just a combination of the first two. So this has already been taken care of by the restriction that we have. So our answer, there's our combined, and then this becomes the restriction. Let's look at something a little bit more complex, like number 2. Okay. So we're going to factor the denominator that can be factored here. It's a difference of squares, So we're going to do that. So notice that the first term has an x plus 1, and this is a 2x plus 1. So we do not need to create that term. It means the first term is only missing this piece, and that the second term isn't missing anything from the first one. It's already got what the first one has. It does not need another one. So we only need to change the first one by an equivalent value of 1 of what it was missing. It was only missing that green part. And the second term is not missing anything from the first one. So our least common denominator is actually the 4x squared minus 1. That is the common denominator. So when we clean up the first one, we're going to distribute that 5. And we're going to add the 6 from the second one. And our common denominator we just talked about was the 4x squared minus 1. So we clean this all up. Right? And your restrictions are, look at your denominators, x cannot be plus or minus 1/2. Right? Set each one equal to 0. You end up getting plus half and minus half. So your answer is that. All right. So that's all we're doing. We're looking for common denominators. You always ask yourself, what does one have that the other doesn't? And supplement it by that amount. You don't have to do more. You don't have to do less. Okay? Another example is number 11 that you see here on your screen. This one breaks into those two factors. You'll notice that the first one already has that piece. The only part it's missing is that one. So we're just going to supplement by that amount. And the second one doesn't need anything to match the first one. It already has what the first one has, plus a little bit more. So if we distribute that x, and then add the 3x from the first one, and the common denominator was actually this part. So when we combine everything, this is what we're left with. Restrictions are decided based on the denominator, so x cannot be plus or minus 1. And there's your answers. And that is how we add or subtract and find the restrictions for rational expressions.